Today we're going to take a look at a rule called the chain rule, which is probably the most versatile and powerful rule that we cover in this class. And we'll start off with easier problems. So it states that if you have some kind of a function, well, I guess we'll call it c of x for chain, that's in the form of one function f with another function g of x plugged into that function, then the derivative c prime of x is going to be f prime, the derivative of the outer function, with g of x plugged into that derivative, times g prime of x, the derivative of the inner function. So it'll become a lot more clear with an example what exactly that means. So suppose you have c of x equal to 3x to the fourth plus 2 cubed. Well, you could multiply this out. It would take a long time, and then you could use the power rule, but instead you can go ahead and identify what the outer and the inner functions are. So I noticed that inside the parentheses, that's my inner function. I have one function, we'll call that g of x, 3x to the fourth plus 2. Now what is happening to that function? Well, it's being cubed. So you can think of the outer function as x cubed, where g of x has been plugged into that x cubed. So what does f of g of x mean? It means take f of x and then plug g of x into f of x. So if we take f of x, that's x cubed. We said that down there. Well, we can rewrite that as a parentheses cubed, because whatever we drop into that parentheses is going to be cubed. But in this case, we're not plugging x in, we're plugging in g of x. Well, if g of x is 3x to the fourth plus 2, then that's what's going to be in there. And that's how you separate out, figure out what f of x is and what g of x is, and after that you just apply your formula. So c prime of x is going to be the derivative of f, so let's figure that out. The derivative of f is, the outer function was x cubed, so that's going to be 3x squared. We're also going to need the derivative of g, so derivative of g is 12x cubed plus 0. So now let's just rewrite this formula here using what we found, using f prime, g prime, and f of x and g of x. So this formula states that it's f prime, so we'll write that out, 3 parentheses squared with g of x plugged into that, so that's going to be 3x squared, and then we're going to multiply that whole thing by g prime of x, so that is 12x cubed. So what we've done is we took the derivative of the outer function and then plugged in the inner function times the derivative of the inner function. Maybe one more example will make that more clear. Suppose you have a function, let's make this one, yeah, that's good. So y equals x squared plus 4 to the fifth. So now I'm going to go ahead and present it a little bit differently. Might make more sense this time around. So what I'll do is I'll go ahead and take the derivative of the outer function, 5, but I'm leaving the inner function alone. So I can see that there's some kind of function, you're taking this inner function and raising it to the fifth power. Well, okay, that means the outer function, f of x, was x to the fifth. So I took the derivative of that and then just plugged in the inner function, and then I have to multiply by the derivative of what's inside. Or another example, let's say y, we'll use a different notation. So if f of x is equal to 3x cubed minus 3 to the fourth, then f prime, the derivative, would be 4, leave the inside alone, to the third, and then multiply by the derivative of the inside, which would be 9x squared minus 0. We'll be doing a lot more chain rule problems, so this is a rule that you'll get really used to by the end of the year. Actually, hopefully you'll get really used to it sooner.